All right, class, with this video, we're going to conclude our study on transformations, and we're going to focus on dilations. And dilations are not bad. A dilation is basically, if you've been to the eye doctor and you've had your eyes dilated, you know that your pupils enlarge. If you think about it, and it lets a lot more light in. But even if you've not been to the eye doctor, your eyes dilate naturally. If you walk into a dark room, your pupils get bigger, and if you walk out into the bright light, they become smaller. And it's just the way God designed your eyes to control the amount of light that comes in. But it's a dilation. So when we think about transformations and how we manipulate shapes, we can dilate them. We can scale them up or scale them down. And that scale, the number that is used there is called a scale factor. And so a scale factor, it's the number that controls the dilation. So if we have a scale factor greater than 1, we have an enlargement. If we have a scale factor that's between 0 and 1, then we have what we call a reduction. All right, so if you multiply something by a fraction, it's going to decrease in size. If you multiply it by a number greater than 1, it's going to get bigger. And so let's look at a couple of quick examples. When we see this shape, here we have triangle ABC. It's our standard 3, 4, 5 triangle. And just quickly, I just made it bigger. A prime, B prime, C prime. I did 6, 8, and 10. And so that's taking our standard 3, 4, 5 triangle and multiplying it by a scale factor of 2. And so when I say multiplying by a scale factor of 2, how does 3 go to 6? Well, it's times 2. How does 4 go to 8? It's times 2. How does 5 go to 10? It's times 2. And so that is an enlargement because the scale factor is greater than 1. We could also say, what if we went the other direction? Change colors here. What if I were to go from 10 to 5? Well, that's times 1/2. If I were to go to 8 to 4, that's times 1/2. 6 to 3, that's times 1/2. In this case, that would be a reduction. Going from A prime to A, scale factor is between 0 and 1. So we're going to have a fraction or a decimal, and so that is considered a reduction. So that's the basics of dilation. Let's do a couple of practice problems. I would encourage you to pause the video and try each of these. All right, now that you've done that, let's consider what happens with a scale factor of 3. One way to start looking at this is we see there's 3 units there, and there are 2 units there. All right, so one helpful thing to do would be to say A is at 1, 1, and we know that A prime is going to do this. 3 times 1, scale factor of 3, and 3 times 1. So what's A prime going to be? It's going to be at 3 and 3. What about B? B is located at 1, 2, 3, 4, and 1. So this is just coordinate notation is all I'm writing down. That's going to be 3 times 4 and 3 times 1. And so the new B prime here is going to be at 12, 3. And then C is located at 4 and 3. So what is C prime? Well, that's going to be 3 times 4 and 3 times 3. And so what's B prime? It's going to be 12 and 9. So let's plot these points and see what happens. We're going to go to 3, 3. So there is 3 here. And so there, that's going to be A prime. B prime is going to be at 12 and 3. So if we have 1, 2, 3, there's 4, 5, 6, 7, 8, 9, 10, 11, there's 12. I'm going to extend this line a little bit. 12 and 3. There's B prime. And then what about C prime? That's going to go up to 9. So 4, 5, 6, 7, 8, 9. Got to extend our line there a little bit as well. And I'm going to be just above. So that's going to be C prime. So let's sketch this in and take a look at it and see if we've been successful. What's the distance from A prime to B prime? It's 1, 2, 3, 4, 5, 6, 7, 8. And there are 6. All right, hopefully you caught my mistake there, but I'm not redoing this video. That is 8 to here, but you'll notice that it actually should have gone out to number 12. So I just shortened it just a little bit. My height ended up being the same. That is correct, but that should be 9. 3 times 3 is 9, and 2 times 3 is 6. So you got to be careful graphing these. That just shows to show you how easy it is to make a quick mistake. But let's go to example 2, and again, pause the video, try this on your own. We're going to be doing a reduction, and so number 1 is an enlargement. It grows. Scale factor is above 1. But with number 2, the scale factor is 1/2. So pause the video and try to complete this dilation. All right, so let's go back and let's see. A is going to be at 3 and 2. So we could start off with A is at 3 and 2. And A prime then is going to be 1/2 times 3 and 1/2 times 2. Well, what is that? 1/2 of 3, we're going to be dealing with 3 halves. I'm running out of room here. 1/2 of 2, well, that's 1. And so what if we go ahead and just pull out, you know what, let's just go ahead and do B. What's B? That's 3, 4, 5, 6, 7, 8, 9. So that's going to be 9 and 2. B prime is going to be 1/2 times 9 and 1/2 times 2 again. So that's going to be 9 halves and 1 again. And let's look at C. C is going to be 9 and looks like 3, 4, 5, 6. 9 and 6. So what is C prime? It's going to be 1/2 times 9 and 1/2 times 6. So that's 9 halves and 3. So these are our 3 new points. These are our dilated points, if you will. And so let's put these on the map somewhere. And so 3/2 and 1. So 3 halves, that's going to be 1 1/2. There's 1.5 right there. And we're going to go up to 1. And so this would be A prime. B prime is going to be at 9 halves or 4 1/2. So there's 3, 4. There's 4.5. And we're going to go up to 1. So you can already see this getting smaller. There's B prime. And C is going to be at 4 halves, but it's going to go up to 3. So 1, 2, 3. That is C prime. So there is your dilated image. And you can see how it has reduced by a factor, a scale factor of 1/2. That is a very basic introduction to dilations. I hope it helps. Let me know if you have any questions.